Uh, Today I want to look at finding a good register abstraction for doing memory mapped register writes on the Raspberry Pi Pico from our Zig codebase. Context here is that we've been working on basically using the Raspberry Pi Pico, this guy, without any SDK, right? So you buy this thing, it comes with a bunch of code that goes with it, and we go, no, we don't want to use your code. Nuh-uh, we want to use our code because we're developers around here, competent developers who can write our own code. We don't need your SDK. So we make our lives hard and we do things that way. And we've opted for using Zig. We have an example of something that can blink an LED as well as write to serial. That's kind of where we ended off yesterday. And part of this is trying to find how do we work with the like the registers in this thing. So yesterday we were looking at the UART line control. Can we do this? UART. And we actually had like a pretty mega big bug here where we were trying to work with this memory mapped register line control. And we were trying to set this feature on the chip that does the UART for us. We were trying to say, hey, could you make sure that you're sending 8 bits of data, please? And so we look at this, register, and he's, at some memory address offset by 0x02C. He's got 30 bits, 31 to 8 are reserved, i.e. unused maybe, or like hidden features. Basically like, don't touch those, essentially. And then bits 0 to 7 are the actual things that we want to modify, right? So if we're trying to say enable this 8-bit thing, we're supposed to write, 2 ones to bit 6 and 5. And so we did this, right? We're like, we take this line control register, he's base register offset by, or base address offset by this amount, and he's just like some U32 marked as volatile to tell Zig, hey, actually fucking write to this thing when we write to this thing. Right? Don't like rearrange things. Don't pretend it's a register. Don't do anything. Like actually put it in fucking RAM. Actually write to that address, which does a write to a register on a chip. And what we did was we made a mistake. We omitted 1 0 from this thing, right? Which is a very easy mistake to make, but has a pretty major problem where we just do the wrong thing, and that caused a lot of pain for us, right? So we wanna fix that. We don't want to be doing this. What we've done in a lot of other cases is we might look at something like the UART data register here. So the data register is offset 0, so that's going to be up here somewhere. And this guy, he's kind of set up so he has, bits 0 to 7 are data, and then 8, 9, and 10, and 11 indicate different error cases that can come out. So on this particular thing, we have read only for everything except for the bottom 8 bits, right? So we can model this as a packed struct. We are still technically a U32, right? Every single register on this thing is a U32. So here we're like bottom 8 bits are data, then we have these guys, then the reserved rest of the 20, right? And the problem with this is this thing called narrow IO register writes. So memory mapped registers on this thing ignore the width of bus read-write accesses. They treat all writes as though they were 32 bits in size. This means that we cannot use byte or half-word writes to modify any part of an IO register. Okay? So basically what they're saying is, we're gonna like just, if you write to address, 0x, let's see. So there are 4 bytes, right? So, 10 or 11 or 12 or 13, all 4 of these bytes go to register 10. That's how this works, right? And so what happens in our case, in this guy, we write to the data field, and we have this big warning that we wrote. Zig will probably generate a 1 byte right here. It did. We checked the assembly. However, the Raspberry Pi Pico will interpret this as a 32-bit write from I guess this should technically say whichever register. However, the other elements of UART 0 are not writable, so this is fine. And data is the bottom 8 bits, so the data will go to the right spot, right? This is fucked, right? Because it means that if data was in like the high bits, and we tried to just write to the dot data field here, it would generate a write to one of those higher addresses, and we would go to the wrong spot, right? So this is kind of wrong. This whole idea of us having a packed structure that we can just directly access is fucked, right? It's a lot better than the just raw uint32 because we at least have names for things now. But if we were to ever go in and write to OE here, it would just behave poorly, right? It would generate an invalid write, and so we need to prevent that, I think. So I guess what constraints do we want to hold here? We have these like 32-bit values. We probably always want to write 32 bits at once. Yo, what turned out to be the bug yesterday? Well, I'll show you. This line control register, I accidentally just deleted one of the zeros at the end. So we just weren't writing the bit width correctly. Isn't that fun? Isn't that fun? So we always want to write 32 bits at once, right? We want to prevent Zig from generating like store byte commands, right? Or store half words. We always want to be using store 32 bits. We want to be able to individually modify fields of a register, right? So if we have like say, how do I say this? Like we have all of these fields in data, and say we only want to modify BE, we should be able to do that. And this should come at no cost compared to like setting all fields at once. Right? Both of these things should be cheap. What else do we want? We want the ability to ignore reserved fields, right? So I guess like ignore and not modify reserved fields, right? So if something in the datasheet says reserved, that means we shouldn't touch it. Not just that we should write zeros there, I think. It means that we should like whatever's in there, just don't touch it, leave it the way it was. And we want to not incur extra costs. Is incur the right word there? I think so. Yeah. Not incur extra cost for using abstraction. And maybe like or provide bailout. In some cases, we might want to build abstractions on top, but like something like GPIO access, like sometimes sets like single bits of a whole bit mask. Maybe we want to think about that in some way. Not really sure. I guess like generally should work as if we had no abstraction for all use cases. Right? So, either we need some way to go behind the back of our abstraction when we need to, or we need to be able to express everything we want to express. And so that's the plan, I guess, for today, is to try to figure out what the fuck does that look like. What does that look like? So I guess let's just start. Let's find, this is a good example here. Parry control. This is a good one. Okay, so this is the clock setup. Let's see if we can find this. Okay, so this is clock configuration for the UART input, right? So UART clock is used to generate is like divided to generate a baud rate. So we need to say, where do we want that clock to come from? We want it to come from the 12 megahertz crystal that's sitting on the board because we want it to go zoom zoom. We need to write to bits 7 and 5 and 11, ignoring bit 10 and ignoring, or we probably want to write 11, 10, and 7 and 5, ignoring 8 and 9, 4 and 0, 31 and 12, right? Maybe this is a good guy to start with. Um, okay. So, oh yeah, I guess I also wanted the constraint of, um, oh yeah, no extra cost for using abstraction is the right thing there. So really, like whatever our abstraction is, I think we only want to represent it as like a uint 32. Single uint 32 is ideal. But you have to read the 32-bit reg first, so you can only write one bit in. Is that correct? Or you want to write some function to do that? Oh right, I think in some cases we probably don't have to read. Probably, I think, and we should be able to avoid doing that read if necessary if we can. I think. Not sure. Not sure. Okay. So I guess we're probably gonna have some like register function that returns a type, right? And this guy's gonna take in like definition, I guess, as a type. Maybe. Maybe. If there are reserved fields, you always have to read, right? I'm not sure. I'm not sure because the chip provides some pretty nifty uh special registers. Let me see if we can find them. It would be like around here somewhere. Here. They provide these guys. So we do have normal read write access, but we also have ways to XOR a register, as well as set a register and clear a register with masks. And I think that maybe you could abuse these in some way. I have to think about it a little bit. Reserved fields are not used on that chip, so they really should do nothing. But if you're porting to a new chip, you might get in trouble. Yeah, I mean, I'm also this is kind of more also an academic exercise to some extent, right? I understand that in the vast majority of cases, I could just write zeros to those registers. And I could, yeah, and that's what they do in their SDK. But I just don't like the idea. And so now I'm just kind of curious if we can build an abstraction that works for all of these things. So we'll keep it in mind. Okay, I guess we should think about how do we want to represent these reserved fields, right? So we could make like, const parry control is a register, right? That has, some definition, which I guess might look something like this, right? But do we want, I guess something like this. Do we want to have the reserved fields in here? Or maybe it would be nicer, because it's easy to get these lengths wrong looking at the register addresses. Specifically, like 7 to 0 is 8 bits. This is an easy thing for I've made this mistake a lot of times. Where I think that this is 7 bits wide. It's 8, right? So I have to think pretty hard about this. I wonder if it would be nice to instead like write these as actual, like something like, we have aux source that's like, he has like some range of bits 7 to 0 or something. Maybe we could do something like that. I wonder if that's nicer. Because it's like, that's like easier to copy paste from the datasheet. Nah, I don't think I like that. I think I would rather kind of have it something like this. Okay. Would a switch 0 to 7 work? I guess you would have the same problem where you need to make sure you're doing the inclusive one and not the exclusive one. And then I don't really know what you'd be switching on. Okay. So I guess we want to do this. But it would maybe be nice to specify the lowest bit offset. I'm trying to decide, like, it'd be nice to not either we say reserved is like a keyword that you punch in to the structure that you're defining, and we just ignore reserved fields. Maybe that's fine. Yeah, let's do that for now, and we can come back to that concept later. So I guess we'll do something like this. I guess we need to define this aux source here temporarily. I guess before we get too crazy, also, let's make sure that we committed what we did yesterday. Because I don't think we did, yeah. Git commit end of stream April 14. Okay, let's bring this shit back. Okay. So here we have this hype. Now, what does this guy do? He has to return some structure. And I guess we have to define this in here for this to not fall over. Okay. What does this guy want to be able to do? So, first case is initialize this thing, right? And we want something in here, or like clobber, like set everything without regard for its initial state. Is that something we can do if there are reserved values? Maybe not. The only way that I know to completely ignore the reserved bits is to use or and only write the bits you're concerned with. Not sure how you can accomplish that with the Zig abstraction. Yeah, and I'm also not sure if you can do that atomically with their these guys. I guess you probably can't, right? You have, like, if you were to call set on write and then clear on write as two individual calls, you might put the register in an invalid state before that. So maybe, can you reflect on the field name if it contains reserved, ignore it? Yeah, we could do that. I don't know if I want to do that, but we could. Maybe we do something that's like, we could mark if it has reserved. Wait, we could kind of do something like this. And we could go like, has reserved on a type. And here we go like inline for each field of the type. If like field name starts with reserved, return true, return false. Okay, so we can be like, this guy has reserved definition. Okay. Can we like conditionally define functions? Is that a thing that we can do in Zig? Can we do like if has reserved? I guess not, huh? Yeah, that's not something that we can do. I guess we could do if has reserved comp time unreachable. Or something. You could do function in struct trick with if and if else. Oh, is that something you could do? You can do like if const clobber equals if has reserved else void. Is it like something like this? Is that what you mean? There's like, I know I've seen, but the function clobber inside a struct. Really? This is crazy. No way. Holy shit, that actually works? That's crazy. Ew. Ew. I think I'd rather do this. And we can do like compile error here, like clobber should not be used with reserved if register has reserved fields, we'll say. That seems reasonable. That seems reasonable. And then clobber will just take in the definition. And probably self as well, huh? Volatile, probably. Or maybe just self, and self holds the volatile U32. Yeah, that seems good. I guess maybe we put the value here too, huh? No, this is a type. So it's like this, and then this guy gets like initialized. Yeah. You're mad about my typo? And regsitter. And then like I guess this guy we init him with a adder, probably is a comp time int. I think is the way that this makes most sense. We go return pointer reg equals pointer from int on adder. Okay. That's not crazy. And then on clobber there, we can just do the right. So with the definition has to be a packed U32. Right? So can we, I guess we could do like size of, we want to like assert that this thing is one of these, right? So I guess we can do like std meta like type info on definition. And we do like switch on this info, and we try to ensure that it is a structure with some struct info, and we want to check that layout is packed. Yeah, nice. So if this is not equal to packed, then that's an error. You know, register definition needs to be packed. And if the backing type is packed, does packed say what he's backed by? No. So we need backing integer. So if this is not equal to U32, register needs to be backed by U32. Okay. Nice. Nice. And then I guess else we have a compile error of register definition needs to be a packed struct U32. Sure. Yeah. That seems reasonable. Okay. So otherwise though, now we're kind of chill in that we can just take the definition that was passed in and write it as a U32, right? We can just do like reg.star int from. Can you cast these things? I assume you can, but I don't really know. Packed struct. You can bit cast or pointer cast. Nice. Okay. That's kind of hype. Okay. So that works in cases where we don't have reserved. Wouldn't a register comp time be? Wouldn't it be register comp time size comp time t packed struct size be better? No, because they always have to be U32s. Every single register is a U32. So we don't have to parameterize that. But if we did, that's not a bad idea. I'm not against it. And then also, I guess, I don't know if this works this way. I don't think that you can put this here. Because if you're like, I want this to be a type, then T has to be a type as well. And you would have to do some sort of like compile time insertion inline, I think. Right? I don't think you can write like struct here. Right? That doesn't really work. Because struct is a type. So you would have to take a type and then do some checks on that type inline. Okay. So we have clobber. That's kind of nice. What about setting an individual field? Right? I kind of feel like we want to. This guy needs some sort of function that's like set aux source, right? He needs something like this. To aux source, right? Right? He needs this. Because otherwise, how else are we supposed to set one of the many fields here? Because, well, I guess let's just like pretend that we were writing this, and how would we do it? Right? We have options here. We have read, modify, write of the full register. We have atomic bit mask, clear, atomic bit mask set, and atomic XOR. So I think technically it's better to use XOR here. Can't you do struct with optional? I think that incurs some runtime cost. I think. Right? Like, let's start with what would I naturally do, and then we can find the right answer after. Right? So naturally, I would be like, val is a definition equals bitcast from a read of self-reg, right? It would be something along these lines. And then we would say val dot aux source is equal to source. And then we would say self-reg dot star is equal to the bitcast back, right? Now, technically, there are two processors on this guy. So if both processors are modifying this guy, you could clobber what the other guy is doing, which we'll probably just not care about But the SDK here, I think, uses the atomic XOR here, where I think you can do something like you make like bit mask the segment that is aux mask or aux source. Then you like do like val XOR I guess it would be like you would do like you would make a mask let me think for a second. You would do like you would make a definition that's all zeros. Yeah, I think. So you'd be like we'll just say that we can do like bit cast of 0, I guess. Right? And then you could do val.source is equal, or aux source is equal to source. So then you have zeros everywhere except for the values that you want to be an aux source. And then I think you do like val XOR aux source, and then you XOR that back in or something. Something like that. Or like the initial val. It's something like this. You do like this, XOR this, masked off with mask, and then you XOR this thing in, or something like that. Something like that. But I think I just want to ignore that for now. And the nice thing about having this abstraction this way is that we can definitely choose to ignore that, which is sick. Because we can like come back in and fix that later, and it will apply everywhere, which is nice. Okay, so for now, let's just say that we do like a read, modify, write on this thing. Is this something that we can generate? Like, I know that I can generate yeah, you can. I guess we would need this to be some sort of like set register val, and this would have to be like we'd have to get clever here. So we have the like type of the field of the definition, right? We would have the register as a volatile U32. Okay. Then you would have the field, probably. Which field on the definition we're setting? Yeah. And then the type of the field. Okay. And then we could do all of this just kind of comes for free. So this is like field val of field is equal to, oh, we need the value as well. Okay. So that kind of works out here. But can we, I don't know how, if we can like generate functions like this in Zigland. I don't know if it would, like, I don't know if we can say automatically that we have this function. You know what I mean? I don't know if it works that way. I don't think it does. Like, you can generate type info on the fly, but I don't think the functions that come out of the type info, I don't think that you can like generate them, right? You can have declarations, and each declaration has a name. But like, see, like the fields you can generate for sure, right? You can just be like, here's its name, here's its type. But generating declarations is not that straightforward. So I don't think that's doable. Which means that if we wanted to do it this way, it's almost like we generate the Zig code in like a pre-build step. Right? If we want this register structure to have set aux source as a function on it, we just have to have a pre-build step. We need to generate the source code, which is fine. I'm not like against that, but is that the right answer? Right? Someone in the chat is suggesting like you could have a modify function that is like kind of type shenanigan. But I don't think that's as nice. Okay, so another option here is that we write out this function for every single register, right? So instead of generating this as part of like the register type, we would have like, we would manually construct, like we would not do this. We would generate something that like extends this guy. Oh, that's definitely something you can do, right? You can like merge two types together. So you could do something like extend register of this guy with some other struct definition, but I think that's getting too fancy. I think what I want to do is I want to do the code generation. That feels like the nicest way to do this to me. Because that way you have the code all there as well. You can jump to definition on it. You have the autocomplete. Everything just kind of works nice. And then also we're no longer restricted to this mechanism of defining the structure. We could like define it in like a JSON blob, right? We could have some like generate register types, right? And he could take in a JSON blob, right? And our JSON blob could look like, you know, I guess it would probably be something like an array of register definitions. And then in this guy, we would have like, probably actually a dictionary makes sense here. We call this Perry control, like this. And then in here, we're just like aux source is, you know, from A to B. You know, kill is like bit, you know, kills like bit 5, 6, like 11 or whatever, enables bit 12. We could define it this way, which isn't crazy. SDK uses an SVD file and generates a .h that has all the pointers and stuff. Yeah, I mean, this is basically what I'm saying, right? This is very close to just what I am saying. Yeah. And then like, so my only problem with this approach is that we're missing the ability to define this aux source type, right? So sometimes we have enums that are nice, pleasant ways to represent kind of like the options that a field can have, right? So if we look at the Perry control register again, right, we would want to have these options defined as an enum. So maybe our definition would be like, we'd have like types registers. Maybe within this we have fields like this. you know, and then we can say that this is each of these needs like a type associated with it. So this would be like type U1 field or like offset yeah, something like this. Maybe we just kind of do offset 11 by default. But then we have like an override for aux source here where we're like type aux source. Yeah, that feels kind of nice. You know, like whatever. And then in here you have like types. Aux source is, you know, like enums maybe. And then in here you can just enumerate the values. That's not crazy, right? You could do like, you could kind of do it like this. That would be good enough for now. Do you know Lua code? I don't know how to code. I gave up, but any advice to learn if you're brand new to coding and not give up? So just don't give up. Yeah, it's a good answer. But like, yeah, I don't. It's hard for me to give advice to people who are new to coding because I've been doing it for so long that it's hard for me to get into that mind frame. But I mean, for me, it's always been, as far as I remember, like I don't think I really set out to learn to code ever. I think I had problems I wanted to solve where coding was the best answer to those problems. And so I can't give you advice for you because I don't really know you, right? But I can tell you what works for me. And that's like allowing myself to rabbit hole into something that I'm interested in and just like embracing that concept. And so you're like starting with I want a skill has just never been something that works for me. Something that works for me is like I want to solve this problem. And then you learn a skill to solve that problem. And then for me, the act of learning itself is very satisfying. And so it's almost like find an excuse also, right? Like right now we're working on this Raspberry Pi Pico thing, and we're doing that technically because at some point I said I want to remap the paddles on my controller. And so then I was like, I popped open the controller and I found a chip. I'm like, I need to read the data off this chip now. And then I was like, now I need this Raspberry Pi Pico. I need like, now this is a way to read off the chip. And now I have to figure out how to use this thing. And like, none of what we're doing right now is like so far removed from trying to remap the paddles on the controller. There's better ways to do that. We could have got there faster. But like, allowing myself to rabbit hole on something that I find interesting that is on a path to something else I find interesting is a good way to trick myself into learning, I think. Anyways, that's my thought, but who knows if that's reasonable or correct. I'm okay with this. This isn't crazy. This looks actually so much like when we did our like Wayland compositor. This is starting to look a lot like those definitions. Maybe Wayland.app is dead. Wayland XMLs. Oh, okay. Oh, this was it. Right, so if we look at like Wayland.xml. Right, we had like interfaces that had functions on them, and then they had enums on here, I think, as well. Yeah, they had enums with entries. So this is kind of like analogous to that. It's not crazy. I think using JSON for now and defining it ourselves instead of using those SVDs, I think is an easier path to get that done today. right? Because we would have to write an XML parser again or pull one from somewhere else. I don't really want to do that. But we have a JSON parser in the standard library of Zig, so that should make our lives relatively easy. All right, yeah, fuck it. Let's do that. Let's do that. So can we do like registers JSON? And let's just copy paste this shit and try to generate a structure. And we'll see where this ends up. Okay, so we need to make sure that this thing is valid JSON, which it seems like it's not. What's it pissed off? So probably these guys all need quotes. We can't have trailing commas in this language. So it's got to look something like this. No trailing comma. And then let's actually make sure that we get the right answer here. So it's here we need to define the size of this guy. So this is bit size, I guess. And then we'll say, can we do set shift width equals 4, tab stock equals 4, expand tab. Okay. We're missing this guy, and then we'll do fields like this. Yeah, fuck it. That seems kind of good. Oops. Kill and disable new quotes. Oh yeah, true. True. Okay, so it's aux source is 3 bits, offset 5. Then we have kill at 10 and enable at 11. Okay. Yeah. We might want to do maybe location. No, offset feels good. Like maybe if we do this and then check that bit size matches, that's probably a good safety check. And then I guess if this guy was a U2, we would do this. Yeah. Okay, that seems fine. We'll start here and then we'll work our way up. Okay. So yeah, fuck it. Okay. Okay, so just kind of nuke all of this crap. I guess maybe comment it out for now. And let's make, generate register types. Okay. Are you more productive with or without music? Dude, you've asked this like 40 times. I don't know. It depends. If I'm like trying to think, if I'm like really struggling to think about something, the music can get in the way. Sometimes it's nice to just have something to like keep you excited, right? It's kind of like about vibes for me, right? If I want to get like pumped up, sometimes it's good to just fucking crank some emo. Oh my bad, I just really want to know probably. Yeah, I mean, I eventually answered, so you wore me down. Guys, remember, you should always try to wear people down, especially people you're trying to date. Just like every rom-com has ever said, just wear down people you're interested in talking to until they talk to you. It's the perfect solution. Without being too annoying all at once. So, no, I'm joking. Just for the record, this is not real advice. But it did work in this scenario. Do you pour the milk or the cereal first? Dude, pouring the milk first would make you a psychopath. That would be crazy. You'd be insane. You have to pour cereal first, or else what are we doing? Like, why are we here? Why exist on this earth if you're just gonna pour the milk first? That's crazy. Okay, so I guess we need to load this registers file, huh? I guess we probably need like an allocator. Probably. So can we do this? I'm pretty sure this works. I'm pretty sure the arena allocator does allocate in pages. Because if it doesn't, that's a problem. I think it works that way. Um, create node. Raw alloc of length. Oh, maybe it doesn't. So maybe just like slapping the page allocator in here is not hype. I thought it did. So maybe we shouldn't do it that way. We'll just use the general purpose allocator, I guess. Fuck it. Fuck it. Okay. And then I guess we make an arena out of this. There we go. I've yet to see someone like both Zig and Rust. It's like they're two different people. I like them both. I think they just have like different niches. You know, I've written a lot of Rust, and I think it like works for some types of people and some use like if you're like really like super into correctness, then Rust is like a good choice. Milk first would help you keep very precise milk portions though. You could like weigh the jug too. But yeah, I guess you're right. Okay. What am I trying to do here? We're trying to like load some JSON. So var args stood process args alloc arena. All right. Sure. So then we have args1 is gonna be our register def path is probably this. And then we, open that shit. Current working directory, open file of register def path and I don't give a fuck arguments, probably. And read. What do we want to do here? I guess we want to like get the file size and allocate that much stuff and copy it in. Or we can just allocate a big blob and reset the arena or something. How do I want to fucking do this? After working with my allocators so much, it's like working with the standard ones. I'm like, what do I do now? I don't remember. Let's do this. Let's do a fixed buffer allocator. And we'll just initialize this with like, like 10 megs of memory or something. Rust people are annoying. I do agree with that. Why are you not using Ghosty? I mean, because I'm just I think to change behavior, you need like, I think there needs to be a good reason, and like, I don't think that I have a strong preference. So I just keep using what I use. You know? Let's do it this way. That's nice. Scratch is the wrong word. Linear alloc, I guess, is kind of the name for this. Okay, here we go. This makes more sense to me. This makes more sense to me. So now we can say, like, okay, we checkpoint this thing. And then we can, like, read this shit and then destroy it later when we don't want it. Yeah. But I guess we're just not going to do that. So maybe I'm getting ahead of myself, but whatever. Whatever. Okay. Oh yeah, this is what I want to do. I want to like allocate I guess we just call this alloc. There we go. There we go. That's fine. I'm so indecisive today. This is crazy. This is out of character. Okay. So we're gonna like alloc a bunch of shit out of this linear allocator. Like 5 megs or something. I don't give a fuck. We're gonna read into this buffer. Yes. Yeah. And then we're just gonna shrink it later. So we're gonna be like, read into buff. Yeah. So break block with buff from 0 to size. Buff is equal to, or content is equal to block. Here we go. And then we're gonna restore. Shrink this guy down, I guess. How do you do that? Without my, like, my allocator utilities, I have to think a little bit. And index is equal to, how the fuck does this thing work again? Buffer pointer. Yeah, it's something like this. It's like we take buff pointer plus buff size minus this. Yeah, there we go. There we go. That sounds right. Okay, so we have our content now. Yep. And we parse this thing. Stood JSON parse from slice leaky. There we go. Nice. And I guess we're gonna parse this into like a stood JSON value question mark. Not sure. Not sure. S. What is S here? The content. And options is this. Okay. I don't know, man. Let's see if this works. Zig run. Whatever the fuck we called this thing? Expected use size. True. Okay, so that parsed, which is good. And then I guess we kind of have some sort of like top level definition. Register definition. Definition singular? Sure. So what does our thing look like? He has fields and enums. Okay. And our register field is... I guess this is not an array. This is like a stood auto hash map, I guess. String hash map of... Where the fuck are we? Yeah, to like field definition. Uh, something like this. And so this thing is like a union. It's like one of many options. But I don't know if those things like deserialize nicely here. So maybe we just like slap a stood JSON value here. And then we kind of parse that thing manually, like by hand when we get there. Sure, let's try that. Let's see what happens here. So here we're like, we have an array of register definition, right? Is that what we have in here? Is that true? This is more like this. Oh, oops, so string hash map goes like this. And then can we say like ignore unknown fields? True, okay. Does that still parse? Probably not. Probably not. Area union with opaque, any type, any opaque is not allowed. What the fuck are we talking about here? Operand value is runtime known. The fuck is this thing talking about? It's like reference dash trace. Is this going to give us more info here? Not that helpful, huh? Not that helpful. Fuck. Does this not work? Let's look at the JSON docs, I guess. So maybe we need this. Yeah, we do need this. Okay, so this is like stood JSON array hash map like this. We have to be careful with these. Okay, so he likes that a lot better, which is cool. And so now I guess we can try like, you know, iterating the fields. You know, parsed map. So this is gonna be definitions, I think. And can we just print the definition name? Okay, cool. So that's his parry control, which means that we've kind of done the first thing. Then we're going to look at the definition value pointer. I did my first script. I learned if statements. Cool. I don't really care that much, but I guess it's cool. Congrats. Um, so we're gonna look at fields here. Um, something like this. While each field, we're gonna be like, I guess we print the name. Okay. Like this. He's mad because I need to write map here, probably. Yeah, nice. Okay, so now we have these guys. Hype. Are you actually going to do the atomic right? If you use the atomic XOR, you need to know the current value. Yeah. Unsure. We'll probably just do read, modify, write in place. No atomic. Probably. Probably. Okay, so we have the fields here, and then we just probably want to parse the field type here. I think that's probably what we want to do. So we have like field register field, I guess, is like an union enum. And we have multiple types of these, right? We have single bit, which is going to have an offset, which is probably a U8. Then we're going to have multi-bit, which is going to have, you know, start and end. And we'll write this is inclusive. Inclusive range here. And then we'll have typed. So this is going to have probably like the enum name as well as its offset. I think that these are the three options that we have. That seems pretty reasonable. Right, so that covers this case. Oh, this is gonna actually be a range. So can we do like const bit range? Like this, we have start U8 and end U8. And we'll just write inclusive here. Boom, and then this is a bit range. And then this is also a bit range. Weird name, but okay. You could be crazy and make it a U5. Yeah, I guess that's true. Yeah, I mean, that is technically more correct. Fuck it. I'm on your side. Fuck it. I like it. Okay. So now we should be able to parse that field. So we should be able to be like from JSON. And I guess technically we could have implemented this using, if we call this JSON parse from value, then like it might actually come for free later. Like we might be able to just hook this into something directly. Right? If this, we could then say that our register definition is an array hash map of register field here. And I think it might just work if we have this defined. I think. If this is public. I think. We could try it. If we just write a compile error, this was totally called here, then we'll see if it's trying. It says unknown field. So No, this is not the way. We might have to do JSON parse instead. What is like our source here? Yeah, it's too much work. We're just gonna do it our way, and then we can always fix me conform to JSON parser API. But this is good enough for now. So switch on val, and I guess we have what are our options here? Array. This is going to go to multi-bit. We have like integer. And this is single bit. And then we have our other option is like an object. Right? And this is typed. I think. How many registers do we have to deal with? Probably a lot. Probably a lot. I just finished watching yesterday's video. Doe 8 bits. Yeah, dude. Fuck. And now you can see why we're where we are, completely over-engineering completely over-engineering something to deal. Okay. So if we see an array, I assume that we have like the array value in here. What is the array type here? It's a array list. So here we're saying like, this thing could fail, and this thing should return register fields, right? And if it's like a dot items len, if this is not equal to 2, then we have a fucking problem. Invalid range. Then we want like a items 0 integer. So to say like if this is not equal to integer, return error not range not, or I guess we'll just say invalid range again. Which means we kind of fold this down into an or here. And we can probably check the last guy, which is 1 here as well. Okay. And then we can just return. I guess we need to like try to parse those integers. So we have a items 0 integer, and we try to read this as a bit offset. So we say stood like for like what is the intcast stood math maybe? There's some like intcast that checks if it's valid. I just can't remember what it is. Because if we do intcast, this will just like crash. But I think there's an alternative where it just returns null if out of range. I just can't remember what it is. Stood math. What horror show have I walked into that makes me think you're using JSON to define embedded register layouts? That's pretty much it. That's pretty much what you've walked into. It's we got here, I swear, we got here reasonably. We just took iterative steps until we ended up here. And I think it's reasonable, to be honest. I don't think it's in here. Thanks. I hate it. Yeah. I don't see the int cast I was looking for in stood math. I'm not gonna lie. Oh, cast here. So we're looking for bit offset from a items 0 integer, or else return Error out of range. So this should be array, I guess. R. R. All right. Multi-bit. Start is equal to A, and is equal to B. Hooray! Hooray! Just one more DSL, bro. Let's go. Well, I think we need to go the whole way. We need to parse the datasheet into your JSON definitions. Yeah, that's pretty fucking funny. Okay, so here it's gonna look, I guess, somewhat similar. We're gonna have some integer, so we don't have to check any of this stuff because we just already have it. And then we only have to check one value here. So this is just like I, and this is just offset. And this is single bit equals offs. Okay, cool. Hype. And then this guy is going to be so here we're expecting a type. What do we call it? We said that this was going to be type and offset. Okay. So, or else return error no type. And offset is equal to no offset. Then type. Offset just kind of follows this. So we kind of split all of the array stuff into a function that's like parse bit range from val stood JSON value. He returns a bit range, right? But he can error, and then we kind of take everything that's in here and slap that here. Is val const array equals val dot array, or else how do you do this? Switch on val probably. Sure. I guess we could do the single bit version here as well. This could be like untyped and typed. Then we could do like if we're an array or integer. It doesn't really matter. Doesn't really matter. Range, not array. Let's not get too far ahead of ourselves. Okay, so here we're like parse bit range array, and then return untyped. And I'm actually on this side now. So this is like invalid range, I guess. All right. And then instead of returning this, he returns like offset to offset, right? Yeah. Yeah. Tell me that's not hype. Cool. So now we have this, and then when we get to the array, we'd be like, range is parse bit range offset. Boom. And then type name is switch on type. And if it's not a string, which I assume is a valid type into JSON value. I assume. String, yeah. Like this. Invalid type name. Okay. Yeah. Cool. Now we should be able to turn typed. With like enum name is equal to type name and offset is equal to offset range. Cool. Check that A is less than or equal to B. Yeah, that's probably worth it, huh? We'll call this start is, we can just do this. Why not? We can just support it. Even better. Even better. Okay. Let's see if we can parse this field now. I'm shocked. Oh, of course. I was like shocked that compiled, but it's because we just didn't do the part that was interesting. All right. We have to write try here probably, and then he's probably bitching about stuff. So what's he complaining about? Switch on 49. We just didn't write the else case. Invalid. What are we parsing? Invalid field type, I guess. How's it going now? Multi-bit, true. This is now called, it's just like this. 64, probably have to write try on parse bit range on both of these. All right, that's not too bad. Not too bad. So we have, kill with 10 to 10, enable with 11 to 11, and aux source with 5 to 7 with this type name, which is hype. So we should be able to start we should be able to like start dumping some Zig code. Probably. How does this usually work in the build system? Do you capture the standard output or do you write to a file? If we're like add out like out file name, is this what we want? No, I don't think so. Oh, this is not the run thing. I'm a dumbass. Hold on. We want the run patch elf. So if we were like run patch elf, is there like capture stood out into a lazy path? We could do it that way where we just write the fucking Zig file standard out. That doesn't seem crazy. Let's do it that way. Writer. So output. And then I guess it probably makes sense to like, well, we might want to like format this shit too. But maybe we do that later. It's like it could be a second build step to format the output file, or we could write to like a buffer, then output later. I don't really like using array lists here because not friendly with the linear allocator, but fuck it, doesn't really matter. No, fuck it. We'll just break the standard out. I just don't care. The zig waits let the caching system track the output file, but I assume that the standard output file will also be cached correctly. I assume, right? If we go like run patch of capture standard out, this is going to be like hashed based off of the inputs to the function, right? So I think it's like the same. Click on that link. I understand that this thing exists. I understand that this exists, but I'm saying that I think that it's the same. Right? Both of these generate a lazy path that are like both of these like take an output from the thing based off its inputs. Right? So I think it's fine. I'm not really worried about it. I'm not worried about it. All right. So I guess we kind of do it as we walk our shit. So we have some field. Doing it your way, I think Zig loses track of the input files. Why would it? Why would it? Because like the file run, the run step is still dependent on all of the inputs to the run, and then the output file is dependent on the run step, right? So it should be the same. I could be wrong, but I don't understand why it would be. They both are like assuming determinism. Your build zig is like an enclave. I don't really understand what you mean. I just don't believe you. And maybe I'm wrong. But we'll find out later. It's also easy to fix later as well, so I don't really mind. And if I'm wrong here, that's some solidifying knowledge, baby. we won't forget it if I'm wrong here, and we find out. Okay. So for each field, we're like const name equals struct. Boom. And then at the end here, it is, so once the data enters your build zig doesn't know where it came from, but why not? Am I fucking high? Of course it knows where it came from. It came from the run step. It came from the output of running this file. Standard out is just a file. I don't, like, maybe you're right, but it seems like there's no, like, technical reason for you to be right. Good afternoon, looks like we're doing some code gen build zig. Well, we're doing some code gen in a executable that will be called by build zig. We haven't really got to that part yet. Okay, so here we're like, does this thing need to be a packed struct? No. He's going to have a field in him. Like this. So he's gonna have like reg volatile u32, I guess, right? And then for each field, we're gonna have to write our function that does the actual writing of the register. It can't tell where a blob from inside build zig came from the run step. No, but the blob is a lazy path. They're capturing the standard output to a file, which will be cached. The standard is a blob that can't trace it back to the run step, but like, I don't know if you're saying that like standard output can't be tracked back to what generated it. Of course it can. So if you're saying zig just happens to not track that because they like for whatever reason, then like maybe. But if you're saying that it couldn't be, I think you're wrong. Like of course standard out from a thing that you run came from the thing that you ran and hashed by the arguments to the thing that you ran, right? It has to be. It's the same as the output file. It can. I'm pretty sure it doesn't, which is why the output file function exists. I see. I think that it exists that way because they just wanted to give you options. But again, I could be very wrong there. Like I think that they have the output file argument as a one option because you might want to pass in a file and manipulate the file, and standard output because you might just have a thing that prints the standard out. Things that print to standard output are like uh those are like tools do that all the time. And so like having an option to run that in your build system makes a lot of sense. So, I don't know. All right, what's this do? I guess we want to get rid of these debug prints now. Boom. Okay, there we go. We did it. We have a period control. Okay, so what do we want to do? We want to iterate each field, and for each catching up, what's this JSON file we're using? It's a definition of which bits are relevant in a given U32 and how we want to represent them. Right? So we've just basically copy pasted this from here, right? We're looking at this period control register. Oh fuck. We're looking at this period control register that has, bits 7 to 5 or an aux source, which is going to be an enum of these guys. That's kind of these. We have kill at bit 10 and enable at bit 11. So that's kind of these guys. And we're trying to like auto-generate something that basically abstracts this thing correctly so that we can like, modify one of these fields at a time type shit. Okay, so each of these fields, we're going to have to generate like something that's like function, probably prefix with some spaces, right? Set this thing is camel case. So we're gonna have to think about that. But for now, I wonder if it makes sense then for us to define it in the JSON as aux source like this. That might be better. Maybe even like this might be best. But maybe we do camel case here and then just uppercase the first letter. So we can do like I guess we probably want to like adapt the field name somehow. So here we're going to have to also take in some generated type string and probably return void. This is probably going to take in self. Like this is a name, probably. Okay. We're getting somewhere. So we're gonna like type name here. Hello there. What are we working on today? We're trying to find the best register abstraction, and we've kind of rabbit holed a little bit into doing Zig code gen. So we're taking a JSON file that defines how a 32-bit register is laid out in terms of like fields that we want, and trying to automatically turn that into Zig code that works reasonably by some definition of reasonably. The rabbit hole went all the way down the other side of the planet. Yeah, it do kind of be like that. So this is like, okay, so what did we say we were gonna do? It was gonna be like read, modify, write, right? So we're gonna be like, ooh, hold on. I think my brain's kind of we've gone through all of this, but I think I've kind of changed my mind on the API. This seems wrong. Because here, if we want to set aux source and we want to set enable, right? Which would be like this, right? This would do 2 read modify writes, which is stupid. We should do 1 read and then modify both, then write. Right? Yeah. So I wonder if we kind of rabbit holed the wrong direction. Right? This would maybe look something like this. Then we set the fields that we want, and then we write. Then we clobber definition, but we don't want to be able to clobber definition with something that we like. If the definition has reserved fields in it, then we don't want to we don't want to clobber those. Clobber should not be used if register has reserved fields. So, if you do it that way, you won't avoid reserved inherently. So, we could have like, okay, so maybe what this is gonna end up looking like is we have like parry control value, which is a U32, right? And in here, we have like set aux source. Okay. And then this does the appropriate bit shifting. Oh, I mean, that doesn't feel as nice as just being able to go like, I mean, maybe that's fine. So we're like set enable, and then we do like val and equals, we have like mask, I guess. I mean, having this packed struct was nice. That was nice. Because then this guy is just like, we could have this guy as like, you know, some fancy packed struct. And we can be like val dot enable is equal to enable or something. Like, that's kind of nice. In which case, just having the packed struct directly is fine. But I would like to avoid being able to modify the reserved values by mistake. That's the thing that I want to avoid here. If you read then set, your setting function will only modify the specific offsets, so the reserve can be ignored. I don't think so. I want to like set the whole register at once, I think. So we have to like read the value as a U32 with the reserved fields intact, then just not fucking touch them. So I guess doing it this way is kind of the most convenient, where we can call like, what do? You and equals this thing with, you know, ones everywhere except for where the enable position. and then or equals here with the mask. So we need like some enable mask probably, which is going to be, how do we generate this? We have an offset range, right? So it's like like comp time generate mask probably with start and end probably, right? So it's gonna like look something like this. Which is gonna take in start and end as bit offsets. Yeah. Yeah. Okay. Then you have, I don't know how to define this. I guess you like take 1 to the power of end, or 2 to the power 1 yeah, 2 to the power of end minus 1, end to the power of end minus start. This gives you like 0b111 or something, right? Yeah. And I guess this is a U8 or a U32? Yeah. But then technically end minus start could be the full range. So this we have to be a little bit careful about. If start equals 0 and end is equal to 31, return. And then in every other case, this works. Mask aligned right is this. And then we shift this left by start. That sounds right. So then we're like, could read XOR with the data you wish to write and with a write mask, then do atomic XOR right to the register. Yeah, could definitely do that. I think that's like the most correct option, but I think that's effectively the same in our case as just doing a read modify write. So I'm not really too worried about that. Okay, so then we go like val or like and equals the inverse of enable mask, and val or equals enable shifted. Okay. I guess we'll just call this mask. Okay. Nice. Then this looks like we have to do that clears off that section. So then we need to do like shifted is a U32, which is like as U32 enable shifted left by 11 again. So here we're going to have like start and equals 11. Start and end go in here, right? And then we use start here. Nice. And then we do like self val or equals shifted. I think we can just do shifted without the mask here. Right? I think that's what this looks like. So then our register needs to return a parry control value here. And as long as we don't, if we don't like create a way to construct this guy easily, then he always has to come from a read, unless his whole bit range is defined, in which case we will define an init function here. This is like if only present if entire bit range is defined. I like that. That seems reasonable. And then if you really want to fucking go behind our back, you can just fucking make one of these manually, but you shouldn't. That feels like it might work. I kind of like that. Okay, so now we're going to come back here. And this is like this. So we have like, value name is how do I want to define this? Do we create like formatters? That might not be crazy. I guess just allocating it is easier and fine. We don't really give a fuck. There, type name. Okay, so now we can use value name here. This guy becomes a U32 now. Pipe. And I guess we need that generate mask function that we wrote here. This guy needs to end up in the beginning of this guy. So we like take this and we just kind of slap this like this. Sure. And now this set function can be like, we can basically write what we wrote here, right? So we're going to be like, okay, like this. Yup. And here we just have to make sure that the start and end numbers are defined correctly. And then everything else just kind of works. Maybe? So what are we looking for here? We're looking for the value name here? No. We're looking for the field name caps or field name Pascal case. We're looking for the field name Pascal again, as well as the value name here. Okay, so we get field name, value name, field name, start and end. So here we need to go like register field is register field from JSON of field value pointer. And then we can be like, we need to have like a type name here. Type name. Okay, so if we are untyped, he is going to return U plus the bit range size. So I guess this is not compile time, so we can't just do plus plus. which means we take an allocator here, I guess. So here we're like alloc stud format alloc print, and we take in the allocator, and we're like u plus the range. Right? Boom. And so now our bit range needs a function len that returns end minus start plus 1. So returns end plus 1 minus start, I think, is less in danger of overflow. Okay, cool. And then typed, it's the same shit. So I guess it's more like len here is like this or like this. And then we return std format alloc print alloc. Oh no, I'm a dumbass. If it's untyped, it returns that. But if it's typed, it just returns t enum name. Yeah. Yeah. This is making sense. This is making sense. Okay, which means down here we can be like, okay, let's val gets register field type name. Okay, hype. So this. Then we have the start. So we need start and end here. And then I think that's kind of it. Okay, field name Pascal. This is a duplication of type name with the first character is uppercase. Okay, because we expect a camel case name on the way in. And then we haven't defined the start and end functions yet. Here we need our allocator. This needs to be tried. And then probably we want to like reset the allocator at each element here. I don't think there's any like cross generated allocations that we care about, I think. I think. We might get into trouble there. Why doesn't he like this? Probably because this needs to be tried. Now, type name exists, but start and end don't. So we have function start returns a bit offset. And here he's like range start. And here he's return t offset start. Boom. And then we have end, which is just these. Boom, boom, boom. All right. Type name, he needs the allocator here. Cannot format error union, so which one? Type name probably. Okay. So this is wrong. I'm a dumbass. It's the key pointer here. Okay, set aux source with aux source, set kill u1, set enable with u1. Pipe. Pipe. Now we're missing, you know, maybe a little flavor new line here. Maybe another one. Maybe a leading one. Okay, that's looking pretty good. And then this is a lot of duplication, which makes me think that this should be like one function. So also enable here is wrong. So really, what is happening here? We're like, we have some function that's going to be like, Wimax, thanks for the tier 1. Much appreciated. Much appreciated. So this guy goes here. Bam. One, two, three, four. Okay. So start and end, he's going to take val as a U32 pointer. Right? That makes sense. And then we also need I guess we'll call this out, or like, yeah, out. I guess makes more sense. And then in, or val here as an any type, maybe. And this is like a bit cast here. And this is no longer generate mask. This is like set val. And here we probably want to do like a little assertion here that these are comp time values, start and end, and we just want to assure that bit size of type of val is equal to end minus start. And if this is not true, we compile error. Invalid type or something. Don't know if anyone mentioned, but SVT files would be a good input for rich definitions. Yeah, unfortunately, you couldn't find the JSON ones. Find them. Do they exist? I didn't even look. Saying couldn't find is implying a lot more effort than was actually provided. Okay. So now these guys just call like, what do we call it? Set val with start, end, self val and val. Yeah, sure. That doesn't seem crazy. We could rename these. We could rename value to be like the snake case version of these, but I don't want to do that right now. But we could. Does this guy need another one of these? Okay, so we have parry control value here now. And now we should just need parry control register. So parry control register should be relatively easy to generate as well. So this guy is going to have a volatile U32 pointer. And I guess he's going to have like function read, which will return a parry control value. And this is literally just like a bit cast of reg. Right? Something like this. And then we have like function right of self with the guy. And this is just like self reg dot stars bit cast of val. That seems kind of nice. And this is just like, okay, first argument is type name. And maybe this gets a little postfix of register on all these. Maybe. And then we have value name and value name, I think. Doesn't seem necessarily wrong. Too few arguments. 1, 2, 3. I think we fucked up. We need double braces everywhere. Yeah, okay. That's not crazy. Now these guys need to be public, and then probably actually the value field might want to live inside the register. Probably. So we probably just kind of move this all up. So like just kind of before we do anything. And then we just don't write the end. Okay, what's that look like? So we have parity control register with this stuff, then parity control value inside. Everything in parity control value needs to be indented now. Nice. Nice, 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 nice. That's not bad. Okay, so the only thing missing now is the enum of aux source. Right? Everything else in here looks kind of generally kind of correct. Okay. So set aux source. So we need to go here after we do all our setters. I guess we have to iterate over all of the enums and write those down. Which doesn't exist right now. So we need to make one of those. So these are still going to be JSON maps, but they're probably going to map to some like enum definition. Right? Which has bit size and fields. I'm just gonna write U8 here. I'm not really sure. Hi, have you ever made a 3D engine? Check out this video. I was pretty proud of this guy. Let's see if we can find him. This one. This is about the extent that we've taken it to, but I would say that it was a fun day. It's a fun day. We definitely understand like the fundamentals. For sure. Okay, so bit size here. Does it explain the math and stuff? Yeah. It's like built up from first principles. That was one hell of a stream. Dude, I think I was wiped as fuck after that one. I was like so brain dead for like a full day after that one. But it was a fun one. It was fun. Okay, so we have bit size and fields, where each field is going to be, I guess, a enum field definition, which is oh, this is not that nice. This is more like a std JSON array hash map of, I guess, like U32s or something is probably the best answer there. It probably depends on the bit size, but U32s are good enough for now. That video is great. I recommend it to a friend that wanted to learn graphics programming. The other one I always recommend this to anybody who's starting on 3D programming. In video games, the player never moves, I think is what it's called. This video is an absolute fucking banger. This video fucking bangs. It's so good. I think it's like the best intro to 3D programming I've ever seen. SVD to JSON looks usable. Oh, hype. Well, we're already like invested on this path, but this would have been nicer. But we're already deep on our way, so I guess we'll keep going. But maybe in the future we'll adjust. Okay. So I think this is fine. Can we at the very least just like print the enum now? I just want to like see what the fuck we've got here. So we have like E key pointer and E value pointer. Like, what the fuck are we looking at here? We have a bit definition. We have an enum definition, bit size 3 of aux source hype with the fields of. Oh, this is not very easy to look at. Okay, cool. So I guess here we are printing we're creating these guys as like some constant, right? We're like const this guy's name is equal to an enum backed by u bit depth. Yes. And then in here we have what is like E key pointer and then E value pointer. Hello? That can't be right. I don't really believe the autocomplete there. Enum definition bit size, my bad. Too few arguments because I forgot this again. Gotta double brace that shit. Okay, so we have an aux source backed by U3 hype. And then in here, I guess we probably have to iterate over this stuff has to go below. You know, something like this. I don't know. Okay. So now we have to go over each field. So for var enum, can we do a field iter here? Enum fields. Yeah. While enum field next, we have some fields. And then here we're gonna have to write like its name and its value. And then probably at the end, if it's we want to write out that it's a non-exhaustive enum. So we probably want to do something like this. Probably something like this. Yeah, it's probably something like this. I don't know. We'll see. Okay. So for each of these guys, we just go like output, write all the name. I guess we would print here is nicer. So we just have name is equal to value. Yeah. And then here we're like f dot key pointer and f dot value pointer. Enum field, I guess. Area is ignored. Try here. Sure. That's pretty close. That's pretty close. We're missing some commas. Pretty good. I guess this needs to be indented even one more. And then maybe one new line in advance, huh? That's pretty fucking sick. If that works. There's like a, I'm sure that we fucked something up here. We need some publics as well. So this guy probably needs to be public. Probably this guy needs to be public. And then probably all of our enums also need to be public. Oh, that's pretty fucking sick, dude. If that works. That is pretty sick. Okay, so can we try to integrate this into the build now? So here, probably like kind of towards the beginning, we're gonna have like gen registers, sure. Name is gen registers. We have root source file, b path, build gen registers elf, or something like that. Target is host because we are running on us, and optimize debug's fine. I don't give a fuck. Then we're going to run this thing. How does this thing work? We add file arg appends an input to the arg command line. So this is gonna be b path with registers JSON. Okay. Maybe this should go under source. Not really sure. This is under source. Maybe this should go under build. Not sure. And then we go run gen registers, capture standard out. And we say this is the like registers zig file. And then we build this thing, right? So we say like add module who has a name, registers, and his root source file is registers zig, like this. his target is the actual target. And I think, is that all we have to do here? Does he even really need this? Because we're going to add this as a module to the executable. So here we're like registers comes from registers mod, I guess. Does that work? Let's see. Let's see. Not quite. So gen registers. Yeah, I don't know why this is .elf. I don't know what the fuck I'm smoking. Okay. So now if we're like registers, import registers, and we try to use that for parity control, how fucked do we get? Like, parity control. Okay. Okay, so I guess this kind of goes away. And we say this guy is parity control register. And here, I think we forgot to make an init function. Feels like we did. So can we add one? I guess these need to be public functions as well. And we need like a init function. Yeah. I guess this can return this and returns like something like this, you know. He's like reg is pointer from int of reg. Boom. Which should let us, when we use this thing, be like registers, parity control register init, like this. Right? That should do something. Too few arguments at format. So this is just probably pissed off about like something that we formatted in our shit. Invalid format string. What the fuck are we looking at? Double curlies again. Oh yeah, nice. Good eye. Good eye. Okay, so he's mad at that bit size of check here. We just didn't fucking semicolon that shit. Now he's mad at I actually don't know what. It's at 24. Oh, sure, that return on the init needs a semicolon. True. Okay, now he's mad at our usage of these guys. So at main, we should be going like parity control val is clocks parity control read. Right? Then we have like parity control val set aux source. Right? It should be something like this. So all of these guys need to be public as well. Okay. So then we have set kill to 0 and set enable to 1. And then we say clocks parry control right parry control val. If that works, that's hype. It doesn't, because he expected U32 found const U32, so these guys, the modifiers, need to take in self by pointer to modify. Okay. Then set val returns something, which I guess just he shouldn't. He shouldn't return shit. Okay. Cannot bitcast from pointer control value, which doesn't have a guaranteed in-memory layout. True, because this guy needs to be packed struct U32. And then that bitcast should be okay. Double C, oops. Now he's mad that the bit size of val is wrong. Okay. So let's just see if this is wrong on all of them or like just one. So if we set it on enable, he is getting hit. So set enable, he's like, yeah, the set val here needs to be +1 on end minus start. I forgot. Let's see me end +1 minus start. Okay. Promising. So he's like expected type. I got the as backwards here. This is as U32 1, not as 1 U32. Okay. Bitcast destination type U32, but U1 has 1 bit. Okay, that's true. So we want to do as U32, then a bitcast. Oh, we can't do it that way. Oh, interesting. So val might be like an enum that is like backed by a U2 or something. So we can't bitcast this straight to U32. We have to like bitcast it to the correct type, which is weird. That's very interesting. That's annoying. Can we do that? What's the error? It's that we have like aux. We have like enum aux source is an enum backed by U3, right? And we're trying to turn this into a U32. Can you just remove the bitcast? I wonder. Oops. I just left that shit in here. Oh, I didn't think that would work. Okay. That's kind of cool. That's kind of sick. So that compiles. Whether or not it's right is another question. Oh, this has to, maybe this doesn't compile. Yeah, okay, that as does not work. So we might have to do some like type shenanigans here. We might have to do something that's like a 2 like int type or something, right? Where here we don't even really know what the type is. So maybe like a t comp time t gross. Maybe it's not even easy to type here. Yeah, here we go. Here we go. So we switch on the type info of t. And if it's a struct, we have the struct info. If it is a integer or whatever the fuck. Can I jump to definition of this? No, 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 fine. Stood built-in type. So we have, what are our options here? Int is probably the one. Yeah, and we look at the int bits. Yeah, so here we're like, I guess if it's int, we just return t. Because it's like already what he wants to be. But if it's a struct, we have to construct an int out of this guy. Int from enum. But the problem is that we don't even know if he's an enum. I guess this should be enum here, not... I guess it's kind of like this. Oh, so we can just do this. Oh, that's not that bad. Unknown, unhandled field type, I guess we can call it. So we can kind of slap this in here. Right? And then we can call that here. Something like that. Something like that. And then actually I think this has to be as U32 here before the shift, I think. Gross as it is, I think that's the correct sequence. Okay. No field name int. Is it lowercase? I fucked that up. Can that bitcast from aux source. Use int from enum. Ah, fuck. Gross. So we actually have to, like, I guess we don't know if this is an enum or an int in here. So we probably have to do, like, another, like, something like this. This is gonna be nasty. But I think it's like lowercase to int type returns to int type of t, a val or something. We take in val here as any type. And then here we would be like switch on type info type of val or something. And if it's like enum, we do enum from, or int from enum. And then if it's int, we just return val. And then else compile error on handled field type. That seems like maybe the right answer here, because then here we can just be like to int type of val. There we go. You should have named it unhinged int type. Thank you. Thank you. Helpful. So he's mad about, what's he even pissed about here? Did I forget a comma? Return this. Expected comma after initializer? What the fuck is he talking about? He's like mad at 14. Am I fucking stupid? This feels correct to me. I thought we were using a packed struct. Packed struct for the register type, not the enums within the register type. Maybe we should fucking make this a zig file like Greyhatter said. But I want to be clear that this is not for the reasons that Greyhatter said. I'm not giving that to him. But I do think that this should be not captured via std out anymore because I want the syntax highlighting. So here we're just gonna be like, const output file path is args2, and then when we do output, it's not from std out, it's out file.writer, and we have outf is current working directory create file with output file path, and I don't give a fuck arguments, probably. All right, let's see if that works a little better. You're missing a closed parentheses in the switch, I believe. Ah, nice. Okay, so now if I jump to definition on main registers, we get syntax highlighting, hype, and it does look like you're right. We did just miss a bracket. I agree. Too many brackets. Okay. That compiles. That's kind of hype. Cool. Cool. Now, API-wise, it would maybe be nice for us to be able to, like, write all. So there's kind of one more piece of this where it might be nice to have, like, from definition or something. No. I don't really have the right answer there. This is probably fine. This is probably fine. Now the question is, does this work? Open OCD. GDB. And I guess, what do I want to do here? I probably want a breakpoint right here and make sure that the value that we're setting is sane. So carry control val 2176. 880, maybe we want B. Can you print GDB binary? I think there's a way to do it. It's just not B, which is confusing. Can I trick you into using type instead of emitting code via std out? But we're making functions, so there's no way to, like, create function definitions that way. I don't think. I could be wrong there, but as far as I understand, it doesn't work that way. There is. Well, get fucked. Okay, so here we want clock source 4. We want enable. So we want the 11th bit to be on. 0, 1. Can we just do this? And 1 shift left by 11. Okay, so that's hype. And then 1 shifted left by 7. 6, 5. 5. So 7, 6, 5. This feels wrong. This feels like it's off by 1. Right, this feels like it should be bit 6 that's set. Which means that probably... How the fuck did we fuck that up? So this calls set val with bit 5. I mean, we could just step into it and see. Okay. That's weird. Monitor, reset init. Continue, next. Oh, oops. Monitor, reset init. Continue, next, step. Okay. So we have the mask now, which is 1, 0, 1, 2, 3, 4, 5, and 6 are set. Shouldn't it be 5, 6, and 7? I think it should be 5, 6, and 7. +1 again. I keep fucking this up. Okay. Okay, that's more right. So this is 0, 1, 2, 3, 4, 5, 6, 7. Cool. P shifted. 0, 1, 2, 3, 4, 5, 6, 7. So this feels wrong. It's maybe start is too high. Oh, that just is the number 4. I'm just a dumbass. So 4, that is the 7th bit. I'm just fucking stupid. Right, of course. Okay. So then how was it working before with the incorrect mask? 0, 1, 2, 3, 4, 5, 6, 7. Oh, because we weren't using the mask for ORing, only for ANDing. And so it just happened to work. So it's a good thing that that bug happened, or else we would have not noticed. But that seems pretty correct. That seems correct. Okay. Cool. Cool. I think I am cool with that. I think we call it there. I consider this a success. We're going to have to add register definitions for the rest. There might be something that we missed in that, but I don't really see why. I think that was like the most complex one. Right? So I think we're probably good. And we can just apply those to the rest and then we won't fuck up anymore. Hooray! Do I think this is like good? I don't think it's that bad. I don't think I have a option I'm happier with. 2 hours and 40 more minutes for just set one reg. Shut up. Did you check the implementation for microsig? We might as well take a little peek skis. What do they do here? Do they do code generation as well? Interesting. Okay, so they have modify here. Interesting. So what is... Oh, so they have... Oh, we considered this. So this is an anonymous struct. I assume modify takes in an any type and then just iterates the fields or something. Fuck. Where are we gonna find that? I guess we could run this tool on the SVD from Raspberry Pi Pico and compare. But I mean, it would be kind of nice just be able to like search this for .modify. Oh, I guess that's not helpful. Function modify, maybe? Oh, that's on the README. Fuck. Not that helpful. My concern here is that I want the autocomplete to work correctly, right? So if this is doing what I think it's doing, and it is just allowing you to set like make an anonymous struct with any fields, and it just iterates the ones that you put in, I think that's not great. And then I don't know what they do with like reserved stuff in here either. That'd be interesting to look at, but I think I'm happy with what we did here. The only thing that would be kind of nice is if you could do like it would be nice to be able to do, you know, this, but I don't think that this is like trivial to set up. I guess if you created one like set known fields or something, and you created a structure like this, and then you just have to fill out every single thing in it, that's not too crazy. Not too crazy. We're also kind of missing the getters on this guy. So if we ever want to read a value that comes out of a register, we're gonna have to implement some getters on these guys. But that's I think trivial to add from what we have. So I think we call it there. I'll probably do some off-stream work to clean that up. This went a little longer than I expected to. I was gonna do like a happy hour post stream today, but now I'm not motivated to anymore. So it is what it is. Oh, you've got the function signature for the. Yeah, it uses the any type there. Yeah, got it. You could set return the value and chain the sets together. Yeah, true. But I don't really feel like the builder pattern. I think is just like it's like a. How do you say this? Like, it doesn't matter. It's just there for like aesthetics, and I don't really care enough to do it. It's like so much more code for such like a minor convenience improvement, right? Because to do it that way, you need like, I guess you could just have it so that sets return the value again. You could just kind of do this, but it's just like weird because then in the cases where you don't want to do that, you don't want to chain, then you have to discard, right? And it's like, I don't know, man. This is fine. This is fine. So I think we. Oh, I guess what I want to check here. One more thing to check is that what does this generate in terms of like disassembly, right? So if we do this, so in debug mode, it's doing something pretty fucking stupid. I think. Yeah, what is this? So he's literally branching into each of these functions, right? He's not optimizing them out, which is not hype. But if we did d optimize is release small, I assume that kind of fixes itself. Maybe we do have to monitor reset init disassemble. We want to continue till we hit the trap, disassemble from here to like plus 10 or something. Yeah, so here he's just storing 0 offset from R3. Okay. I'm not really sure what this is doing. LSLS, what is that? Okay, what we could do though, we could bookend this with breakpoints. And then that will at least tell us where this shit ends. That's not helpful because it reordered. Okay. Oh, but again, this isn't helpful because he's probably didn't breakpoint before the read. God damn it. Oh, maybe this is still kind of shit. Where's... Oh, so it's like this. So maybe it's not folding everything down into one right, which isn't really ideal. It would be kind of nicer if the compiler was smart enough to figure out how to mask all of these rights together. So maybe there is some improvement to be had there. Because in reality, like, what we really want for something that has like no extra cost is we want this thing to like do the equivalent of parry control val equals like and equals combined mask, and then or equals combined right? This is kind of the ideal, I think. You have to compute the value and then write it, but these are all compile time known values. So I think that you could do something in just like a couple instructions. Like maybe like 2. Where our disassembly is like not that. Right? But I'd have to think a little bit harder about like what this is doing. Because clearly like 25 instructions, or like not 25 instructions. Call the function with comp time. Oh, that's not a bad idea. Oh, but I don't think you can do that because it depends on a runtime value. So you'd need like comp time functions to generate the masks and then apply them. You know what I mean? Because I think that this is maybe I'm wrong, but I think this is applying individual values. But I'd have to think harder about this. Anyways, right comp time right there. I'm pretty sure that doesn't work. Pretty fucking sure, right? He goes like, he can't resolve because I'm pretty sure it's because this guy's not comp time. Oh, you want like this? I don't think that changes shit. There's no way. There's no way that changes anything. No way. Yeah, I think this is the same shit. But anyways, it's fine. We'll think about it. But good progress for today. At the very least, it's not that bad and prevents a bunch of the problems that we could have hit. So, I think call it there for today. Thanks for watching, guys. If you like what you saw, we stream most days at around 12:30 Pacific time to 4 o'clock Pacific time. It is just before 4 now, so anywhere between 3.5 hours ago and now is when you should expect to see us live. If you want to keep up with the project, there's a YouTube link in the Twitch description where you can follow along with most of the feature development. We stream a little bit more than we post to the YouTube, right? So if you want to see everything, you either have to catch us live or subscribe on Twitch, join on YouTube, or on Patreon, where we post like the remaining content. Please consider supporting on those platforms or on GitHub, but on GitHub you don't get anything. But please consider supporting. This content will end someday, but that day is marked by when I run out of money, right? And so every dollar we make extends the lifetime of this stream a little bit longer. But if not, no worries. I think that's all we got to plug. YouTube, peace out, and Twitch, let's find someone to raid.